So we have to go back and use rules that we're familiar with. If you look at commutativity, you'll recognize that? Right. So x plus y is the same as y plus x. We know that already. X multiplied by y is the same as y by x. Associative, if somebody gave me x plus y plus z, I can add the x and y, or I can add the y and z, and I'll get the same answer. Multiplication, same concept. If you have x, y, z, and you're multiplying, you can multiply x by y, then by z, or y by z, and then x. Distributive, x by y plus x by z. Right? Every operation has an identity. Right? Identity means when you add it to that value, you'll get back the original value. So x plus 0 will give you x. 0 is called the additive identity. Right? What is the multiplicative identity? 1, right? So the multiplicative identity is 1. So you see this here? This rule is important. A star E is equal to A. That is the rule to find the identity element, right? A, by any function, once it gives you A, that E is the what? Identity element, right? So we're going to use a matrix method next day to work out these things, right? What is the additive inverse, right? A plus minus A is 0. So it means that the additive inverse is negative A. Multiplicative inverse is what? 1 on A. All right? What you all recognize about the additive inverse? What you getting? Which is the identity. So you would recognize here that there's a rule. What's your rule? A by B, B by A, giving you E, then B is the inverse. So if I give you a matrix and I have to just show that in matrix commutative, we have to show that A star B is equal to B star B. Okay? So let's see if we can find A star B. A star B is equal. You see that? You have to read it. A star B is A. Okay, looking for where they intersect. All right. Okay, so we just said that A star B is A. What is B star A? What is B star A? A. So it appears to be commutative, but that's not enough. We have to show that the whole, every single combination is commutative. So what you do is just check and see if the matrix is symmetric. Right? So in your mind, fold the matrix here. Fold the matrix along a diagonal. Are they identical? Are they identical? Yeah. If you're not seeing it that way, you have to do. Take a row and transpose it. Make that row a column. Is it identical? Yeah. Watch it good. D A B C. D A B C. That's okay? Try it again. Take a next row and make it a column. Is it the same? Yes. So once you identify that, the matrix is said to be symmetric. Okay? Once the matrix is symmetric, commutative. Okay, make a note of that. How do we find the identity element? A star E have to give you back A. B star E have to give you back B. Which of the elements will do that for you? So to focus on one of these columns. Look at the columns there. Which of those columns do you think shows the identity element? Think about it again. A star something given you A. The answer is what? B. What about B star B? Also given you. What about C star B? Also given you. And then D star B also given you. Right? So once you find an identical column to the first one, that is your identity element. Okay? Make a note of that. An identical column to the first gives the identity element. Okay, so in this question here, the additive identity is B. So we shall find the inverse. A star the inverse always gives you what? The identity, right? And the identity here is B. Okay? Find the inverse of B for me. C for me, please, and B. Find the inverse of all. What's the inverse of B? A B star something given a B. What's the inverse of C? C star something given a B. C star A, right? If the inverse of A is C, inverse of C is A, then the reciprocal should be Q, right? Right, Genesis has no D there. Think about it. D star something have to give you a B. What is that? B, correct. D star D given you a B. Yeah, that's it. First thing, see with commutative. Right? Is it symmetric? Yes, because if you transpose it, you'll get the same thing. So yes, the matrix is symmetric, therefore it is commutative. Next, what is the identity element? What is the identity element, Shivish? Right, so the identity element is Q, right? The identity element is Q, is identical to the first. Find the inverse for all quickly. P star something given in Q. What is that? R. Yes, R. Q star something given in Q. Right, Q. Right, R star something given here. Q. P. And last one, S star something given in Q. Okay. All right. That was that, right? The next thing that we have to do is proof, right? We have to be able to do a direct proof, proof by counterexamples, proof by exhaustion, proof by PMI. We only have to focus on the first and the fourth. All right. But before we do that, there is something missing here. Something called closure. All right. I want to explain what that term closure means. All right. So let's take a look at it on the whiteboard here. Right. What does closure mean? Watch here. There'll be a delay. Right. Watch here. Let's say I gave you X and Y, and I said that X and Y are real numbers. Right? X and Y is elementary real number system. Remember this? Real number system, right? You all remember the real number system? All right. I'm gonna start over, right? Obviously, you may know that, right? You have a few systems, right? The first system that you need to know is natural numbers. Anybody remember what is natural numbers? Natural numbers is all the whole numbers that not including zero. Then they expanded natural numbers into whole numbers. Whole numbers included zero, right? And then they expanded this further into integers. Integers include negative values and positive values. That's okay. After integers, now they had to include two sets of values, right? Right? They had to include rational, which are like what? Fractions and things, right? Like, for example, minus 2/3, positive 2/3, and so on. Right? They had to include rational. Then after rational, they had to include irrational. Irrational will be things like roots, like surds, right? Like negative root 3 and so on, positive root 3 and so on. Okay? Rational and irrational, they have nothing in common. right? But if we combine all the rational numbers and all the irrational numbers, we end up with what we call the real number system. So the superset or the universal set in all of this is a real number system. And the symbol for it is R. Right? R plus is all the positive values, R minus all the negative real number. Right? So whenever you see R, they're referring to this. Okay? Right? So the universal set is this. These are two subsets and everything inside rational. Okay? So if you needed to draw a little diagram, right? So Q and Q hat make up this, and all the others are subset of Q. That's okay? Rational and irrational. Right. Coming back here now. We need to understand the term closure. Ready? So let's say I gave you some value, X and Y values, right? And I said X and Y are always real. How do I show that a particular function is closed? Right? So if I want to say, well, it is a star closed, right? Let's say that let's say that X star Y is X plus Y. How do I show that this function here is star? How do I show that this function here is closed? Right? Here what you do, right? All you have to do, and this is a real simple version, Antonio. All you have to do is check and see if X plus Y will always give you real values. Right? So think about this. X is real, Y is real. If we sum X and Y, it will always be real. Correct? So no matter what X is, it's real. No matter what Y is, once you sum two real values, you will always get something that's real. Correct? Yeah? Once you can show that, therefore, close. That makes sense? That's if it closes. So it'll give you X and Y belong to a set. And once the function belongs to the set, then it's closed. Try that some up. Try number 2. Right, so here you can use something called a proof by counter example. So all you have to do is show one example that this will not work for. Right? So for example, let's choose an integer, X is 1 and Y is 2. 1 and 2 is not an integer. That's okay? 1 and 2 is not an integer, therefore it is not closed. And there's no such thing as open. So do right, it is open. Right? That's right, it is not closed. Okay? So number 1, you have to understand here. Symbols, right? What Z represents, what W represents, what N represents. Okay? Right. The next thing that we have to do is something called proofs, right? So there are 3 main ways to do it, but there are more. There's proof by exhaustion. Means that if I ask you to prove something like this, proof by exhaustion means you are going to choose every single real number, put it in here, and show you again something real. But you see the problem with exhaustion, right? Too long, right? So you're not going to use that. When you would use proof by exhaustion? When you have a small set, right? A small set like 4 or 5 values, right? A next type of proof is proof by counter examples. So you see here, technically we provided a counter example, right? When x is 1 and y is 2, right? We showed a counter example where this is not true. So by showing this, we're able to show it's closed. Okay with that? Then there is direct proof. You've been doing that all the time. You remember this? Sine squared plus cos squared is 1. Yeah. Left hand side equal to right hand side, but that's like a direct proof. And then you have PMIs. Right? PMI is going to be new. Okay, you might get to do one today. Head up direct proofs. Let's do a couple. Head up direct proofs. Let's jump into a couple of examples for a time, right? Example 1. Prove that the sum of two even numbers is even. Prove that the sum of two even numbers is even, right? So when you add an even to even is equal to even. So some of you might say, okay, nice. So if I add 2 and 4 again, 6. That's enough? That's not enough. Right? So if you want to use this method, you have to use proof by exhaustion. So you have to list out all the possible even numbers and show you getting something even. Will that work? Well, it will work, but not you won't finish that today. Or no. Right? So we have to find a next way to do this. Right? How do we represent an even number generally? How we could represent an even number generally? Even numbers are what? How you know 4 even? Right. It's a multiple of 2, right? Correct? It's a multiple of 2. So an even number could be written like what? 2 by, right? So an even number is what? 2z, right? Okay with that? Why do we write here? What's the odd number? 2z plus 1. Nice. How do we show that even numbers are always even? Well, let's take the left hand side and add them, right? First even number, 2z1 plus 2z1. When you add up that, you will get 4z1. Well, something like that, right? And what I could do here is what? How I could show this even? How I could show this even? Right, factor the 2. Factor the 2 and you'll get z1 plus z2. Once you do this, you know it's even. So once you can show something is a multiple of 2, it means it's even. All right. Let's go again. Number 2. Something similar. Prove that the sum of 2 odd numbers is always even. Prove that the sum of 2 odd numbers is always even. We said that the sum of 2 odd is always even, right? So take the left hand side. Odd number would be what? 2z1 plus 1 plus 2z2 plus 1. Right? The reason I'm using z1 and z2 is that it can be different numbers, right? Add it up, you will get 2z1 plus 2z2. 1 plus 1 is 2. And now I can factor out 2. And I will get z1 plus z2 plus 1. Once I can show this, it's even. So if x is more than y and k is less than 0, show that xk or kx is less than ky. Show that kx is less than ky. Try it. Think about it. Think about a value, right? If you multiply by a negative here, what is happening? What's happened? Sign the slip, right? Think about that. See if that helpful. All right, so what do we know? We know that x is more than y, right? Yeah. Can I bring the y on this side? Yeah. X minus y is more than 0. That's okay? And if we multiply by k, what will happen? You will get k by x minus y, but remember, k is less than 0, right? So what will that do? Flip the sign. Multiply this out now. Kx minus ky is less than 0. Can I move this now? So I'll get kx is less than ky. Let's try one more now. Given that x is less than y, given that x is less than y and k is more than 0, prove that kx is less than ky. All right, good. So same thing. X is less than y and k is more than 0, right? So x minus y is less than 0. When you multiply by k, x minus y, this value is positive, so it will not change the sign. Multiply it out. Kx minus ky is less than 0. Kx is less than ky. Does it? Okay. I want to show you the last proof now, right? It's called proof by mathematical induction. All right. Just take a look at this here. Suppose I wanted you to show this, right? 7n minus 1 is divisible by 6, right? One of the ways to do it is to list out every n value and show that it's divisible by 6, right? But proof by exhaustion too long. So what we can do is a PMI, right? PMI is a particular proof that allows you to skip out some steps and prove this. So the first thing you do in PMIs is just put in n is 1 and show it holds. If I put n is 1 in there, and I will get 7 minus 1. Yeah, good. Second step is that, remember, in proof by exhaustion, and you'll do this 1, 2, 3, 4 until you reach infinity. Right. So here's what PMI does. PMI allows you to use the first value and some value later down the road called k, and then k plus 1. So once you could show that it's going to work here, it'll work for anything. Right? So PMI is basically this. First value, not always 1, but first value, we're going to assume it works here, and we're going to prove this here. This is the statement we're trying to prove. Once we can prove this, then holds for everything. That's okay. So these are the steps PMI. Right? And it's 1, show it holds. We're going to assume one of these steps is true. So we're going to assume n equal to k is true. Second step, right? Third and the most important step is that we're going to prove it works, so everything holds. Prove it holds when n is equal to k plus 1. Once we can show these steps, then we can go to step 4 and we write the answer. All right? So we are going to do that here together. So I'm going to do proof by mathematical induction. And I have a statement. The statement of proposition is 7 to the n minus 1 is divisible by 6. Everyone ready? Right, good. Let's take a look at this here. Right? How do we do that? So 7 to the n minus 1 is 6, right? So since it's divisible by 6, we can say this. we can say that 7 to the n minus 1 is equal to 6 by some letter. Correct? So when n is equal to 1, we're going to get 7 to the 1 minus 1, which is 6. Right? Which is of the form 6 by 1, therefore it holds. Are you okay with that? It holds, right? That is divisible by 6. Right? Right, next we're going to assume it holds for n equal to k. So instead of writing n, we're going to write 7 to the k minus 1. This has to be divisible. So let's put 6 and let's change the letter. Okay, that's a different value. Are you okay with that? So 7 to the k minus 1 is equal to 6. When you reach here, sometimes what we just do, different textbooks have different methods. When you reach here, you can make something the subject formula, right? So I will make 7 to the k the subject formula. So that'll be 6b plus 1. So I'll use this later on in proof, right? So now we're going to show it holds for n equal to k plus 1. That's okay? So therefore, left-hand side, 7 to the k plus 1 minus 1. We're trying to show that this is a multiple of 6. Okay with that, Brianna? And now we're going to start. Right here, the proof starts. All of this doesn't change. So all you have to do is just change the numbers. But this doesn't change. Here's the proof starts. That's okay? So what we're going to do here, we know that whenever we add in the same base, we can multiply, right? 7 to the k by 7 minus 1. That's okay? But and we know what 7 to the k is. 7 to the k is 6b plus 1. So now I'm going to substitute here. So I'll get 7 by this, right? Which is 7 by 6b plus 1 minus 1. That's okay? Brianna, you're watching it like somewhere wrong there? Tell me. So I had this line. All I did is I took off the n and I put k plus 1. That's this line here. 7 to the k plus 1 is 7 to the k by 7 to the 1. Correct? I know what 7 to the k is. 6b plus 1. So I take off 7 to the k and I put 6b plus 1. I'm going to multiply this out now, and I'll get 42b plus 7 minus 1, which is 42b plus 6. What do I do now? I can factor out 6. So I'll get 7b plus 1. Right? And this is of the form 6c. That's okay? I'll have to just step here. I should have said that this is 7 to the k plus 1 minus 1 is 6. I left out this line underneath it. Right? And then I took this left hand side. You're okay with this? Come here. So I make a substitution, I multiply it out, and I was able to show that this is a multiple of 6, which means it holds. Right? But you still have one more line. The last line is, since it holds for n equal to 1, n equal to k, and n equal to k plus 1, then by proof by mathematical induction, it holds for all I didn't tell you that there, sorry. All natural numbers, right? And the symbol for all is this. Right? It holds for all n eta integers. Right? Actually, most times it's natural numbers. Are you okay with that? Yeah? All you have to do is this part here. maybe correcting the subject and the formula and substitute. Okay, this is called proof by mathematical induction. Oh, I can't see the last line. The last line is then by PMI, it holds for all n is natural numbers. Just like this. 6 to the n minus 1 is divisible by 5. Right, quickly, and we're done, right? Change this to 6, change this to 5, 6 to the 1, 5, this is 5, so it holds. So here we have 6k minus 1 is 5b. So this is 6k is equal to 5b. That's okay? Here, here, sorry. We have to change this to 6 and change this to 5. Change this to 6. And we do the same thing, right? Multiplication, addition here means multiplication. And then we can say 7, sorry. Right, I know it's a little bit lazy, but it's just to show you how easy it is. We just put your numbers, right? 6 to the k is 5b plus 1. And all we're going to do, I'll do back that step. All right, I want to just do back that step there. I'm going to substitute here. I'll get 6 to the 1 by 5b plus 1 minus 1. So this is 30b plus 6 minus 1, which is 30b plus 5. Factor out the 5. You'll get 6b plus 1, which is of the form. And then you have to write this line. Of course, we'll make it more challenging next day, right?